Hey guys, we're in chapter 2, unit 2, topic 2, however you want to look at it. This is where we're talking about special solutions. So, special solutions, we'll see equations here with one solution, just as an example, to kind of like contrast the other two, which is how what we normally see, just equations with one solution. We'll also see equations with infinitely many solutions and no solutions. So, those are the special parts of it, right? So, the great Carlo called twins Jasmine and James onto the stage. And then has this kind of like math sentences, these math sentences right here. So Jasmine, multiply your age by 3 and add 6, then multiply this sum by 2. And then James, multiply your age by 2 and add 4, then multiply the sum by 3. I predict you'll get the same number. What a great magic trick, huh, guys? Oof. All right, so we'll define our variables as x equals age. So our age is right here. Multiply your age by 3, so that's 3x. Add 6. Then multiply this sum by 2. So we take that whole thing and multiply by 2. And since he's predicting we'll get the same number, we say equals 2, right? We got James, multiply your age by 2 and add 4. And I left a little space here. Then multiply this sum by 3. I predict you'll get the same number. So yeah, let's simplify this a touch so it just like makes the next step a little bit easier. Since we have these parentheses, first step is that should go to that 6, my bad. So we're going to distribute 2 times 3 is 6x, 2 times 6 is 12, and then 3 times 2 is 6x, and 3 times 4 is 12. Look at that, 6x plus 12, huh? Okay, choose 4 whole numbers for the twins' ages, and twins' age, yeah, I guess. And test each expression, make a table to show the numbers you tried and the results. So I'm just going to do, I don't know, let's just do small numbers. Let's do 1, 2, 3, 4. All right, so 1, 2, 3, 4. So 6x plus 12. I'm going to take, that's our x value right there. Boom. We take 6x plus 12. We're going to say 6. I'm going to plug in 1. Okay. Plus 12 equals 6 times 1 plus 12. This gives us, let's see, 6 times 1 is 6. 12 plus 12 is 18. So 18 equals 18. Okay, so that worked there right there. And I'm going to just do the same thing for each of these, but I'm going to do the variables in a different color. So I'm just going to kind of do my framework right here so I can just do it real quick. Plus 12. So then I'm going to multiply by 2, 3, and 4. And then 2, 3, and 4. Okay. 6 times 2 is 12, plus 12 is 24. And on the same one, 6 times 2 is 12, plus 12 is 24. 6 times 3 is 18, plus 12 is 30. And then 6 times 3 is 18, plus 12 equals 30. Okay. 6 times 4 is 24, plus 12 is 36. And the same thing on the other side. Okay. So what do you notice about your results? Well, even though I don't need to come there, we had different expressions originally. On each side originally, it gave us the same answer on each side. Excuse me. So like just as an example, right, you got 18 on this side and 18 on this side. So yeah, that would be an example of infinite solutions. It's one of those special solutions we talked about. Okay. For what values of x will the rectangular and triangle have the same perimeter? Well, so you've got 2x plus 2 for each of these sides. This is an equilateral triangle, meaning all the sides are the same. This is a rectangular. This is a rectangle. So we know that opposite sides are going to have the same measurement right there, right? So I've got x and x, 2x plus 3, 2 of those, and then 2x plus 2. So what we're going to do is we're going to set, since it's the same perimeter, we can set them equal to each other, right? So I'm going to do 2x's is 2x, and then 2 times 2x plus 3 right there. Okay, and then we've got 3 of these, so we'll just say 3 times 2x plus 2, just like that, right? Yeah. Okay, now we want to solve this. It's kind of already given it away that we're going to have infinite solutions right here, right? Okay, so I'm going to distribute here. So I end up getting 4x plus 4x plus 6, right? Yeah. Okay, and we distribute here. We end up with 6x plus 6 right there. We simplify here. We get 6x plus 6. And we can kind of see we had that same situation in the previous one, where it's the same on each side, right? So I'm just going to subtract my x's from each other, cancel them out, and we get 6 equals 6. This is infinite solutions whenever you see something break down to this. Okay? Yeah. Yeah, I don't know. Whenever you see it's just a number equals a number, that means basically any x value will make this true, right? So you could actually solve it a different way. Let me do it over here. 6x plus 6 equals 6x plus 6. And then rather than subtracting the x's, you subtract the 6's, cancel, and you get 6x equals 6x. You divide by 6, and you get x equals x. Kind of the same situation, right? Basically, any x value you put in here is going to make it true, because it's going to be like x equals 7 equals 7. Put a 7 into each of these x's. Over here, you get the same number as you did over here. So infinite solutions, and you see it set up like that, like an answer that comes to this or this. You can also see it at this point, right, when it's the same on both sides. Okay, so if you see that and you understand what that means, you can actually just be done at that point and just write infinite solutions. Okay. Anna and Lee played soccer for the same number of hours 1 week. How many hours did Lee play on Sunday? So that's our Sundays right there. Okay. All right. So Anna's got she practiced twice a day, 2 a day. So x plus 1.2 for Anna. She did the same every day. So 1, 2, 3, 4. So 4 times x plus 1.2. And then it does say they played for the same number of hours each week, so we can set them equal to each other. And now Lee's got all kinds of different stuff over here. He's got x plus 2.5 plus 2x plus 4.5. Okay, so let's solve this. So we distribute here, we get 4x plus 4.8. X and 2x gives us 3x, and then 2.5 plus 4.5 is 7. So we subtract 3x here, right? We move our variable term from the right to the left. So we're at x plus 4.8 equals 7. We subtract that 4.8. That's 2.2. So x equals 2.2 hours on Sunday for Lee. Oh, and just to be very clear, guys, on the previous one, the answer to this is infinite solutions. It's not 6 equals 6. This is your work, but the answer is infinite solutions. Right? So yeah, this dude played 2.2 hours of soccer on Sunday. Yeah, about that. Okay. All right. So let's see. So we're going to do an equation with no solution here. Gil makes 3 bracelets and Mika makes 2 bracelets. They both have the same number of string colors. How many colors should they use to make the same amount of money? So x equals the number of string colors. There we go. Okay. All right. So let's see. String colors are x in there. So let's see. Gil makes 3 bracelets and he's multiplying it by 2x plus 5. Okay, so 3 bracelets and then 2 per string color plus 5, right? Because that's you're paying that per bracelet no matter what. And then Mika makes 2 bracelets and then 3x plus 3. Okay, now we distribute. 6x plus 15 equals 6x plus 6. Okay, so now we'll bring the variable term from the right to the left. Interesting. What's going to happen here? These cancel out. We end up with 15 equals 6, which is not true. Okay, so whenever you see something break down like this, no solution. There are basically since their pricing is different, right? they're never gonna. They're the same amount of money they make is never gonna line up. Depending on how many bracelets they do, it's never going to be the same amount of money. So no solution to that one. I'm going to pause this to go get my son. Oh, let's see. Yeah, there you go. No solution on that one. Okay, determine the number of solutions by inspections. Yeah, this is kind of like where you see the result of what's going to happen before you actually finish solving it. So let's see if we can do that, right? So we're going to simplify things over here. I want to combine these together because they're just regular numbers. So I end up with x plus 10. 2x minus x, I'll combine those two together, is just x. Oh, right. I have the same thing on both sides, right? I could keep solving it, but I know that if it's the same thing on both sides, it's going to give me infinite solutions. Okay, so you see that and you just write that, you're good. You don't have to worry about any more work. This right here, we're going to distribute. We're going to get 3x. Is that right? Yeah, plus 10. Yeah, okay. Plus 12 after you distribute equals 3x plus 12. Yeah. Oh, my bad. Previous one, plus 10 minus 10. Sorry, my gosh, guys, I screwed that one up. Subtract 10 over here, subtract 10. You get x equals x minus 20, which you subtract that x right there, you get 0 equals negative 20. So, yeah, no solutions on that one. My bad. I'm so sorry about that, guys. I did not see the, I didn't make the distinction between that plus and that minus. So yeah, no solutions on that one. You can see kind of like where that happens when you get to x equals x minus 20. When you see it like this, you can probably jump to no solutions immediately because you know those x's are going to cancel out and it's going to be 0. So that's your no solutions right there. This one, we've got the same thing on both sides. This is when you have infinite solutions. Okay. My bad. Sorry about that one for A. All right, 5x plus 8 equals 2x minus 1. Well, this is just going to give you one solution because nothing's going to cancel out and make it weird, and it's not the same on both sides, right? So one solution on here, just kind of like how we normally do it. Okay, guys, you're going to fold that in half. Just like so. That's going to go in your notebook. Speaking of my notebook, this is going to go on page, whatchamacallit, 22. 22, 2-4, equations with special solutions. Yeah, equations with special solutions, 2-4. Sorry if it's kind of like not enough room at the end there. All right. Yeah, there you go, guys.